Right. Okay. Good morning, ladies and gentlemen. A warm welcome from my side to the Specialist Forum today. My name is Patrick Stern. I'm product manager from EBM Parts, and I'm gonna show you some, very interesting news about a fan range which we have developed not recently. It's already 3-4 years ago, but I think it's more interesting than ever because it's to do with efficiency, it's to do with ice behavior, and it's to do with throw distance. And I think these are the three very important things when it comes to refrigeration applications with respect to a fan. So that's the subject of my presentation for today, Ready for the Future, the fan for the future. And this is what I'm going to show you. Efficiency requirements of the next ERP regulation. I guess most of you hopefully know about ERP, and that the next ERP step is going to come in 2 years' time, or when it's a built-in component, then in 2027. Then I'm going to tell you something about the ice behavior of that fan. I'm talking about the Icing range and the air throw distance. And finally, I will show you some details about really the fan range as a plug-and-play solution. Efficiency requirements of the next ERP regulation. You know, this is something which we have today, the ERP 2015, which is still valid. With respect to axial fans, we are talking about the N grade, so an efficiency requirement of 40%. This is something we can very easy, I would say, reach today, even with AC fans. But when it comes to the next step, ERP 2026, we are talking about a step from 40 to 50%. So 10% points more of efficiency on an axial fan. And this is really a lot. But, and I would not show this to you if we would not have a solution for that, of course. To make it more visible, I would like to show you that diagram. So you see here 3 curves. You see the blue curve, this is history. This was the ERP 2013. This has been substituted by ERP 2015, which is today still valid. And as I said, the next step is to come in 2026 as ERP 2026. And what you see here on this curve are the efficiency requirements for axial fans. And we are talking, as I said, about a step from 40 to 50%, and which is really a lot. But if we look at the fan range, which I'm going to tell you more about today, I'm talking about the so-called Icing fan range. It's in principle an axial fan with some diagonal flow parts, so to say. And due to this fan design, blade design, we are able to reach these efficiency requirements even with AC fans. And what you see here on these two diagrams, first of all, you see here the so-called Icing Protect. This is the one version. This is just the motorized impeller in combination with a guard, with a basket guard. This can be used as a more or less like-for-like replacement for a typical axial fan you are using today, for an air cooler, for an evaporator, where you just have a short nozzle. This can be also used for this fan because the beauty of that fan is that you do not need really a wall ring around as you typically use or need for an axial fan, because the fan has got its own wall ring, which is turning with the impeller. So you do not need an additional wall ring. You just need an inlet nozzle, and that's all. And therefore, it's very easy to use this fan in case you would like to use still your own short nozzle on your air cooler, on your condenser, condensing unit, whatever. On the right-hand side, you see the other version. It's the so-called Icing Perform. This is I would say, the plug-and-play solution. This is the fan, the motorized impeller, in combination with a full plastic housing, with an integrated nozzle already, and with an integrated guard on the outlet side, and with some guide vanes in order to increase the efficiency even more. So that's really the plug-and-play solution. You do not need to carry out any ERP assessments. What you normally need to do, for example, in that case, if you use just a motorized impeller and you use your own nozzle, your own cone, then from an ERP standpoint of view, you are a fan manufacturer. So that means you have to carry out the ERP measurements and the ERP assessment. In that case, you get a fan as a plug and play. You do not need to consider any ERP regulations because the fan itself is already assessed. It has got ERP measurements and all these things. And furthermore, what you also see on this chart here, as I said, all these colored dots stands for one version of each fan range. So that means we have altogether 5 different sizes. So diameter starting from 300, 350, 400, 450 and 500. That's the diameter of the impeller actually. And as I said, each color stands for one version of each size. And you see here these ERP requirements, the efficiency requirements. The dotted line is the ERP 2015, what we have today. The gray line is the next ERP step, the ERP 2026. And you see here clearly that all these colored dots stands for the point where the fan has got its best efficiency. That's actually the point where the fan is measured. And you see all these colored dots are above the ERP 2026. And as I said, this is not only valid for EC fan motors, it's also valid for AC. So also for this fan range, when it comes with an AC motor, is ready and compliant with the next ERP step. And this can be seen on this line here. Maybe you're a bit wondering about this point here. This is just to show this is the smallest one. This is the size 300. And as it's below 125 watt, it's out of scope of the ERP regulation. Therefore, it doesn't matter. But all the others are above the line, the gray line. So they are, so to say, in the green area. And this is valid for both ranges, for the Axi Eco Protect as well as for the Axi Eco Perform. And what you also see, of course, as I've mentioned before, due to the fact that these Axi Eco Perform comes with a guided vane, with an integrated guide vane on the air outlet side, we have got even a higher efficiency here on that range compared to that. That's just physics. It's nothing to do with EBM. It's physics. It's aerodynamic.
Yes.
So, coming to the next chapter, icing behavior. I think this is really important subject and sometimes maybe a problem when it comes to evaporator air cooler application. And what we see here on the left-hand side, we see the streamlines on a typical standard axial fan, like our high blade range, how we call it. And on the right-hand side, you see the streamlines, the airstream of the Axi Eco fan. By the way, the colors makes a statement about the air velocity. So that means red means high air velocity, and yellow and green and blue means less air velocity. And what can clearly be seen here, that on a standard axial fan, you have somehow a kind of a backflow to the fan. And this is just to do with the airstream. This is to do with the geometry and the design of the impeller. And due to the special design of this Axi Eco, as I've told you, with a turning ball ring, with a turning ring, it's not just a ring. It's shaped like a diffuser, and by this we have less turbulent flow, as you can see here from the color. We haven't got this high velocity here in that area, and that means we have almost no backflow. We have certain kind of backflow, depends on the duty point, but in comparison with this fan, almost no backflow, and that means we have less ice formation on the guard grill of the fan itself, because due to the backflow, you get the warm and the humid air back again to the fan, and this leads to ice buildup at the guard. And ice buildup at the guard means increased back pressure, and that means that you shorten your operating time of the evaporator until to the next defrost cycle. And furthermore, as this diffuser ring turns with the impeller, there is no gap in between. Like on a typical axial fan. On a typical axial fan, you have a certain gap between the wall ring and the blade, and this is sometimes could be a problem because you can have ice build up on the wall ring, and this could mean that you have a blocked rotor. This cannot happen here on this Icing fan because there is no gap, because the wall ring is turning along with the impeller. In the next few slides, you see that it's not just theory. This is something we have actually measured under real conditions. So that means we have carried out a measurement on an air cooler, on an evaporator. We have used the size 350 of the standard axial fan, the so-called high blade. We have used the 350 mil fan of the Icing Protect, and we have used the same size with the Icing Perform. And on these photographs, you see already that the difference between the ice formation, the ice buildup on a typical axial fan, it's quite clear due to the backflow. Here on the Icing Protect is much less, and here on the Icing Perform is almost no ice buildup because we do not have any backflow. What does it mean for the cooling capacity of this evaporator? This is something what you can see here on this graph. So we have carried out a test with all these three fans. We have started the operation, the cooling circle, so to say. And after 1 hour and approximately 40 minutes, we have measured the cooling capacity at the beginning when the coil is free of ice, and we have measured the cooling capacity at the end after 1 hour 40 minutes. And what you clearly see here is that with the blue line, with the Icing Perform, we have a slight decrease of cooling capacity, of course, but you have some kind of ice buildup at the coil, of course, but it's less in comparison to the Icing Protect, and it's much less in comparison to the standard high blade fan. In percentage means that you have here at the end of this would be the moment or the trigger point for the defrost cycle, and here we have got just 77% of the maximum air cooling capacity what we have at the beginning. With the Icing Protect, we have approximately 88%.
Yeah.
And with the Icing Perform, with the standard high blade, we have 66. Here we have got 77. And with the Icing Perform, we have round about 88% of the cooling capacity what we have at the beginning. So you see that's a clear benefit of this fan range. And these are actually measured data. This is not just simulation, this is measured data. So coming to the next chapter, airflow distance. What you see here is a CFD simulation. On the upper picture here, you see again the standard axial fan, the high blade fan in the size 350 in combination with the AC 4-pole motor in a typical installation with an air evaporator, with an air cooler mounted at the ceiling of a cold room. And the picture below shows the same situation, but with the Icing Perform, also in the same size 350 with an AC 4-pole motor. And what you see here is the air velocity diagram, again based on a CFD simulation. And when we talk about airflow distance, we are talking about the point where the air velocity has still got a value of 0.5 meters per second. And this is exactly the point here. So that's the frontier, so to say, between the blue area here and the white area. So here, everywhere you have got the blue color, there's still an air velocity of 0.5 meters per second. And this is how the air flow is normally defined. And you see here that in combination or in comparison with the Icing Perform and the high blade, we have round about 25% in favor of the Icing Perform. So 25% longer airflow distance of the Icing Perform based on the CFD calculation. However, we have done also some measurements really to get real figures, not only a CFD calculation. And that means we have measured these two fans in a hall with a fan standing on the floor. This is how you normally measure the airflow distance. And we have done this in two different duty points. So we have done this here with a lower pressure, and we have done this here with some higher back pressure. You see here also the air performance curves. The yellow is the air performance curve of the standard high blade fan, and the blue curve is the air performance curve of the Icing Perform. And what you can also realize here is the different characteristic of the Icing Perform in comparison to a standard axial fan. That means the characteristic, the performance curve, is much steeper in comparison to the flatter curve of the standard fan. And this is, as you can imagine, the big benefit, because the higher pressure stability, even when it comes to higher back pressure due to ice buildup, due to dirt on the air coil, on the coil, the fan has still enough reserve, so to say, to overcome this higher back pressure and to still provide enough air volume to do the job. So this is what we have done, and these figures, what you see here, these diagrams are really measured data. I need to hurry up a bit. So on the left-hand side, you see the result of the standard high blade fan.
Yes.
So we've got here an airflow distance of maximum, I would say, 14, 15 meters. On the Icing Perform, we have an airflow distance of, let's say, 18, 19 meters. This is at the duty point with the low back pressure. And how it looks like the situation on the second duty point with a higher back pressure. This is what you can see here on that diagram. So with a high blade fan with a flat curve, you see a dramatic decrease in airflow distance of the standard axial fan down to, let's say, only 5 meters. And with the Icing Perform, we still have an airflow distance of up to 10 meters, which is really a great benefit when it comes to a cold room where you still need some airflow to get the cold air also, let's say, at the last angle, at the last corner of this cold room. So this is another big benefit of this Icing Perform. However, this is something what you know most likely. The airflow distance depends not only on the fan itself, on the characteristic. It depends also, of course, on the fan type, of the diameter, of the operating point, as you have seen on that last diagram. It depends, of course, on the number of fans which are installed in an air cooler. It makes a difference whether we have just one fan, 2, 3, or 4 fans in an air cooler, of course. Then what is also relevant is the design of the heat exchanger. So the fin space, for example, it makes a big difference if you have a small fin space or a large fin space, of course, because this is also then relevant for the duty point to the fan. Then, of course, the degree of ice formation on the heat exchanger is relevant. Then the distance of the evaporator to walls or to ceilings makes a difference. And the floor plan of the cold store, of course, and the arrangement of the goods which are inside the cold room. And this is just to explain that the values which we have measured and the values which you have seen based on the CFD calculation is just a rough a rough figure. This is just maybe to compare fan with another fan. Your real throw distance can only be measured and defined when it's installed in your application. And this is really the statement of this slide here. So finally, the Axi Eco fan range is really a plug-and-play solution. As I said, we have two versions. We have the Axi Eco Protect, the guardrail version with a robust and flow-optimized steel wire guard with a very good noise characteristic. Because we haven't got that much obstruction to the airstream, it's very easy to mount just 4 screws. You can use a short nozzle in your unit. No additional valving is needed. And on the right-hand side, the real plug-and-play, the ready-to-install fan with the housing version, with the plastic housing, with the integrated guardrail and the integrated guide vanes to increase the efficiency. And it's with really some flexible fan options, which we see on the last slide here. This is the Axi Eco Perform, so it can be used as a, let's say, which is immersed into the unit a bit by using this mounting flange here, but you can mount it also on top of the unit, and you can use it in the other flow direction by turning the entire fan assembly and mount it from the other direction, and then you have depressing, so you're sucking the air from outside towards your unit. This can be used, for example, for dual discharge units. You just need, in this case, the guard on the sucking side, and that's all. So really a plug-and-play solution. And this is the range, what you see here. As I said, and the size is 300 up to 500 with the different versions. And finally, this is also very important, I guess, for you, the F-gas regulation. All the Axi Eco fans are nowadays ready for also natural, for flammable refrigerants, because this will be the future, as you can see here, from the latest regulation for the F-gases. And at the end, as you know, there will be only natural refrigerants, CO2 and maybe R290 on the market. Otherwise, you have got a problem with in order to be compliant to the F-gas regulation. And we are ready for the future also with this respect. So thank you very much for your attention. I know I'm a bit out of time, but if you have a question, maybe it's allowed. Okay, sorry for this. So thank you again. Have a nice day. Thank you.